Good day. Welcome back to my channel. This is John Vincent Saracanla, and this channel is about research and research statistics. Our topic for today is chi-square, test of relationship, and test of difference between observed and expected results. So basically, when is it used? You can use chi-square to test relationship and to test the difference between observed and expected results. However, I rarely use chi-square to test relationship. I usually use person R because of the two variables that are really connected. That in person R, if the variable x increase, we can see if it's a positive R, but y also increases. However, in chi-square, the results, the relationship between two variables, or the difference between the observed and expected results, is due to a random variable that creates the relationship. So, to test for the results of chi-square, first you need to have your table, so your observed values. Let's say we have an viral infection from the months of July, August, September, October, November, and you have this data, and you have different levels of health conditions. So we have mild, severe, then critical, and these are your results. So first to do is to get the sum of the columns and your rows. So subset equals, it's very easy, equals, then highlight, then click the solve the sum for your columns, equals, then sum, open parenthesis, then highlight the scores, then copy paste. To check, since this is the sum of our rows, our columns, we need to check the sum of our rows. So it's 720. Next is to construct a table with the same number of columns and rows and label it expected values. So this. The question now is how to calculate for our expected values. So it's very simple actually. You just put in equal sign, then open parenthesis, then you have to lock B7, the total score, over multiplied to G4, which is your total for your rows, over lock it to your total of your columns and your rows. Why do we put a function F4 or the dollar sign? So that when you copy paste from here going down, it will just automatically calculate, because as you've noticed here, that's dollar asterisk dollar sign B, dollar sign 7 multiplied to G4. In here it will become G5 and it will automatically count. So again, so just equal sign, let's do it. So let's do this. So equals sum of column, function F4, times sum of your rows, no, do not lock it, over the total. You have to lock that, and enter. So you have that, and you copy. When you copy, you just paste it here, and you know it's correct because the total is the same. And you basically do the same thing here for column B. Instead of locking from A, you lock to B. So that's C. You lock the C multiplied to the sum for G4, then over the total. These are locked, and when you copy paste, it will just follow automatically. So that's how you calculate for the expected values. Next is to solve for your chi-square values. So to solve for your critical value, a probability value for chi-square, you just type in CHI test, open parenthesis, highlight the observed values, then comma, highlight the expected values, then close parenthesis, then enter. So that's it. So do that again. Equals to CHI test, open parenthesis, highlight the scores only. The scores are the responses, and enter. For your degrees of freedom, the formula is to number of rows minus 1 times number of columns minus 1, then times number of rows minus 1. So in this case, we have 1, 2, 3, 4, 5 columns minus 1 times number of rows 1, 2, 3 minus 1. So we have 4 times 2, that equals 8. To get your chi-square, you type in CHI INV, open parenthesis, click your probability value, comma, and your degrees of freedom, and close parenthesis, and you will have your chi-square. So equals to CHI INV, open parenthesis, probability value, and degrees of freedom. Then that is your chi-square. For your critical, chi-square critical, it's different. So you just type in CHI INV and level of significance and degrees of freedom. So that's CHI INV. That's chi-square inverse, open parenthesis. Our critical value is usually at 0.5 level of significance, and our degrees of freedom is at D14, and you will have your critical value. So finally, we are now testing our hypothesis. With all this data, you can do 2 types of tests: testing for interdependence or testing for difference. Interdependence or relationship or difference. So how do we do that? So that's equals to p value lesser than 0.05 is our p value lesser than 0.05. So we'll test. So is our p value, that is p15, is our p value lesser than 0.05. If it's true, then your findings will be this: there is a significant relationship between the months of the viral infections and the health conditions of the respondents. There is a relationship. And if the answer is no, for example, is our p-value like lesser than 0.000, that's false, then there is no significant. However, in this case, it's true. So when you test relationship, you need the following chi-square values. the probability value, and your threshold, your level of significance. Usually it's 0.5, 0.05. Now, for testing difference, we have to check if our chi-square is greater than our critical. So, is our chi-square greater than our critical? It's true. So, if it's true, there is a significant difference in the observed and expected results in terms of months of viral infections and level of health conditions. So that's it. So different statistical tools have different use. When we use chi-square, usually it's used about test of difference between observed and expected results. So looking at this data, what does that mean? What does that mean? This is just the findings. But what does it mean? What does this mean? This means that there is a difference between our observed data from our expected results. Meaning, there is a random variable, something that made the changes from our expected, because it can always be that our observed and our expected, usually it's our observed and expected, there's no significant difference. That's when everything is normal. Everything's normal. Everything just flows in a certain pattern of normality. But once the expected results vary from our observed results, that means there is a random variable that created the changes. And what could that be? So, since we are talking about viral infection, it is possible that since the observed and expected, there is a difference, probably there is an intervention that happened, or something that created higher observations. It can either be that there is a random variable that suddenly decreased the observations, or an event that exponentially or increased significantly the observations, and it's no longer normal. The pattern of normality is changed. So that's when we used chi-square. But you can also use chi-square for testing relationship. As I have said, different statistical tools have different use. In my case, I use Person R to test relationships, and I recommend chi-square in testing the difference between the observed and expected results, because you cannot use Person R when testing observed and expected result. You can only use chi-square. So that's it. Thank you and good day. I hope you learned something. Please like and subscribe. Thank you and have a great day.